I apologize in advance, but I could only spend 30 seconds on a slide, so give me a frown if I spend more than 30 seconds. So I spend a minute, you can throw things at me. I don't need a mic, right? Last time I was in an auditorium this big, I was actually in Canada, in Saskatchewan, where I was an adjunct, and that was more than 10 years ago. So it's kind of fun looking up again instead of doing what I do now when I teach, is just looking at a computer. So sometimes when I look at the computer, I feel more comfortable because that's how I teach my students now. So anyway, we're going to talk about Bristol Bay, and some of you as international audience probably don't know where that is. It's, you know, a great place on this planet. I live in Dillingham. It's not Bellingham, which is another place that is wonderful, some people say, but Dillingham's better. They're both on the water, and actually the climate of Dillingham is getting more and more like the climate of Billingham. If you know where that is, that's in the Pacific Northwest. So anyway, here's just some pictures of it and a little circle of where it's at. And if you know anything about Dillingham and the Bristol Bay region, it is known for salmon. What kind? Sockeye salmon, but it's got all five there. And here is the world sockeye salmon harvest. And you can see everything in red is pretty much the Bristol Bay region. And it does dominate. And as other places don't do as good as a job, I'm being facetious, as Bristol Bay does in trying to maintain those salmon stocks, we'll just continue to making more salmon. And maybe one day, you Norwegians out there will stop making this farm salmon, and we'll, yeah. How do we manage the salmon? Well, actually, it's in principle pretty simple. In reality, it's very difficult. Because we have a fairly pristine environment out there, you just do escapement. And if you just count escapement, you know how many, you know your systems pretty well, and you know how many salmon need to get up there, and you do your numbers and how many eggs there are, and how many sperm there are going to be, and how many eggs are going to hatch, and how many almonds you're going to get, all that. You can basically say, okay, we just let so many salmon get up there, and the rest of them we can eat. Okay? Or we just let go, you know, nature and other things eat, the beluga whales and stuff. So basically we manage by estimating salmon escapement. And there's a picture of the tower on the Wood River, and we use other technologies as well. A lot of interns, a lot of people. I know I've been up there a couple of times, but you just sit there with the tally whacker and you count away every hour for 15 minutes. But why is it healthy here, and why are our stocks so good? Basically, it's because we have this low population density. Unlike other places. You go to Columbia River Basin, they used to have great sockeye salmon. What happened there? Well, people. High population densities and stuff. And they started destroying their portfolio effect. This is Ray Hilborn and Schindler. This is University of Washington's great contribution, but they've been working there for the Fisheries Research Institute has been working in the Bristol Bay region since the 30s. Collecting these types of data, and you can see that some years the Quejack district was doing the best in terms of salmon. In years they went down. Of course, the Nushagak sometimes has gone up and down. And then who never would have figured this little tiny district of the Igigik is really, really coming in strong now. No one expected that, okay? And so by having all these different habitats, as things change, this species, or the salmon populations that go to those certain rivers that are doing well will do well, and the ones that aren't doing so well is because of whatever reason we don't understand, because that's one main thing is we just don't understand. One of the things I love to say, and you'll see me say it all again, is if you ask me a question, my first answer is going to be, I don't know! Especially when you're dealing with an area as complex and not well studied as much as others. Although it's been fairly well studied, especially by, when I said that one time with Ray Hilborn at the FRI at UW, he got offended. He didn't just say that. They've been studying quite a bit. So is there more to manage? That's when I came. I'm not from Alaska. I probably got the job here is because I was a fisheries observer at one time in Alaska, and they were hiring for an environmental scientist, and I was somewhere else. And I said, I wouldn't mind going back to Alaska, and they hired me for my sins, I guess. But is there more to manage? Okay, so, you know, FRI's doing a good job. The state's probably doing those counting towers. They're doing a good job. So I'm like, well, let's start talking about it as a community. Let's start looking at when we do this, why is it FRI? Why is it the state doing the counting? Well, there's good reasons for that. There's history. There's governance. But what about getting it more local? Right? That's where we want to get it. So there's a lot of local knowledge. We want to pull that into the data collection, and basically we want to get into the residents who have the intimate knowledge and tap into that data as well. And then we want to work within the statistics calendar. If you live there like I do, you got to live within the statistics calendar, even if I don't do all the statistics activities, because nobody does all the statistics activities, maybe a few. But you certainly are going to get involved in that just because it's pretty damn cool. So then we started doing data collection courses when I first got there to basically say, here's how we collect defensible data, if you will. And then we work within some of those parameters I just talked about, and we're going to start setting up what I'm calling our hybrid environmental science programs. And that's one of the reasons I was hired. And then we've got to tell people what we're doing, and then we've got to get together and talk about what's missing. And so we've developed, when I say we, it's like we call the BBs in the Bristol Bay region. And other places, they call them other things, especially when we're talking about a regional conference like this International Science Conference, which is all of Western Alaska. BBs, you might know what the BBs are in the Nushagak, Kujak kind of area. BB is Bristol Bay. It's all damn company. Did I say that word? It's all of the organizations that have Bristol Bay in front of them. Bristol Bay Native Corporation, Bristol Bay Economic Development Corporation, Bristol Bay Campus, Bristol Bay Native Association, all those BBs. But we get together with other groups that have similar issues, and we discuss these things, and we're looking for those data gaps. We're looking for what we should be collecting, what should we be studying as a regional community and as local communities. So here's just some two conferences that we had. The first one and the second one we had in Dillingham. We've had a third one now. And of course the whole idea with this waste conference is basically building capacity and keeping it local. That's the whole point. And we now can share the data we collect with each other. Because sometimes you're waiting for FRI to come in, they collect the data, they send it off to Science Magazine. And you're like, okay, not everyone reads Science Magazine in the Bristol Bay region. And then we got a little bit of accolades. I got to pat ourselves in the back, and then this is NSF, and they said, oh wow, big science comes to tiny fishing town. That's not a tiny fishing town. For us, it's a medium-sized fishing town, but that's okay. That was Dillingham. It's one of our conferences. So basically, we want to look at the management of the data gap. What are we missing? Okay, so we look at this kind of Bristol Bay area. You say, well, who's studying the lakes? Well, there's a lot of lakes there. That's why there's a heck of a lot of salmon there, sockeye salmon, because they're the ones that love lakes. And you can see Lake Ileana, the largest lake, the whole Woodchick Lake system's up there. I think you can use this. There's the Woodchick Lake system if you don't know. Then we've got these peninsular lakes. Lots of water, fresh water. And that's what FRI is doing. The Fisheries Research Institute doing. And there are other people there too. And I could have really gone to town like some of you managers out there and made those gigantic charts with all kinds of lines with all the people. I made it simple. So if your organization's not on here and you do that, I apologize in the beginning. I'm just trying to make it simple. So anyway, we'll say the lakes are studied by FRI. The streams, pretty much ADF and D, they're doing those counting escapements type stuff. Okay? And then the marine, well, we got the NOAA people. And they do a pretty good job, but we got this little 2-mile zone, 3-mile zone really, called coastal. Who's doing that? Well, it should be in the state, but not people. Okay, so there's a data gap. There's all kinds of processes going on in that little tiny. And then, of course, we've got even a bigger area, what I think is more important, it's called the estuary. So the coast and estuaries, there doesn't seem to be a major group that's managing those, at least in the Bristol Bay region. I'm making it simple, okay? It's for me making it simple, not for you. My brain sometimes can't handle what you talk about. So, estuaries, we all know what they are, semi-closed bodies of water. Generally, they have to be on the coast, by definition. Usually, lots of human populations. If you look at the Bristol Bay region, I said there's not many people living in it, but where do most of the people in Bristol Bay live? The largest towns and villages are on estuaries. And the same thing too. New York City is in a estuary. Okay? Toronto's not, by the way, for you Canadians, right? Neither is Montreal. Unless you say the St. Lawrence River, no, never mind. Goes all the way down. That would be a big one. Chesapeake Bay is a estuary. Okay? So basically, large human populations live there, and really our knowledge of dynamics is limited. And actually, I worked in estuaries in Jamaica and in North Carolina, so I'm not saying I know a lot about them, but I felt a little more comfortable jumping into it. There's conventional wisdom on estuaries, and basically you got a lot of photosynthesis going on. It grows a lot of seagrass or a lot of spartina stuff, and then of course it has respiration, that you build a bunch of detritus, and it basically becomes a super fresh meat salt, of course. And where's the one I wanted? Somewhere else. But anyway, the conventional wisdom is photosynthesis drives this thing, and it's primary productivity. Right? That's how most places work, but these are supposed to be huge because you got shallow water, nutrients. You don't have to add fertilizer like we do in our agricultural fields. And there's also, of course, we're fresh meat salt, and there's a lot of ecological functions of where these ecosystems, different ecosystems meet, the ocean and, in this case, rivers and streams and stuff. And things go up and things go down, so there are highways and that, and we'll have that later. There's different types. It all depends on currents and how much fresh water comes in and how much salt water goes up and tides and that kind of stuff. So you can have salt wedges, partially mixed. So they get complicated really quick. That can be moved or not moved by the currents that are there. There's various temperature changes that you have. You have wind that's, and air at one time, and you have water at another time. If you have big tides, you have waves and currents. There's various turbidity and oxygen things you deal with in estuaries you may not deal with in the same way in other bodies of water. That's all I'm trying to say. And you got this whole brackish freshwater thing that's going on there. So it's dynamic. And I could spend too much time on that one, so I'll just do that. And then we got your classic food webs where it's all based on the sun, phytoplankton and salt marshes, and then you have your regular trophic cascades after that. And then you have various life cycles where some parts of a fish may live, inside the estuary, moving up to the river like salmon do, or contagious where you go from sea to fresh, which we don't have much of in Alaska. But these life cycles can have a lot of times a portion of the life cycle in an estuary. That's another reason why they're important, right? Here's the one, the conventional. That's the one I was looking for. And then this is very, very, very conventional wisdom, and we're finding it not to be so true, especially in Alaska, is estuaries is one of the most productive systems on the planet. Okay, more so than coastal and open ocean, even good agriculture. We're looking like we're on an Iowa cornfield here, right? So they say. And there's a lot of important ecological roles. For those of you in ecosystem functions, I love ecosystem functions. Estuaries provides a bunch of them. Read those yourself. Pick up a textbook. Of course, there are a bunch of estuaries as havens. A lot of this vegetation and whatnot can protect those life cycles, or like one section of the life cycle as various species go through it in populations. And of course, you get safety from predators, and you got the physiological transition zones for those anadromous, contagious species. And then, of course, there are highways. The highways are the conduits. They may not spend much time there, like some of the salmon smolt. They kind of motor on through, but they have to stay there long enough so they can breathe the water, or at least not get sick by salt. So what do we really know about Bristol Bay estuaries? Okay, so we had the conventional wisdom for the lower 48, other lower latitudes. What do we know about in the Bristol Bay? And major questions we need to ask. What are the drivers of the food web? How does fish processing deal with this? That's the major human influence, isn't it? We're catching 10 million fish a year easily, sockeye out of this. What are the seasonal species migrations? Okay, both fish, birds, whales. How does the salmon smelt influence the food web when they're up and when they come back down? And of course, winter ecology. It's kind of weird. Sorry, I don't know. We need to look at it. So basically, I've been looking at Togiak, Dillingham, king salmon, and Port Haydn. I'm only going to talk about Dillingham today. So here's the Nushagak Estuary, which the estuary which Dillingham is located on. Here's some beautiful pictures. Dillingham. Here's my lovely wife on ice floe, not wearing a life jacket. Risk management, you can see that. And we've got large tides in most of Bristol Bay. Anywhere from, it goes from a negative, this is the range, right? -1 to 7 meters, and as you can see from this bouncy line over here, it doesn't necessarily do that all the time. This is just a couple days ahead of us. But it's pretty significant tides. This is the same boat right here, from this to this. Okay, I'm almost done. So people have been studying this for a while, and it's basically a freshwater estuary. Wait a minute. Where did that salt thing go? Well, for reasons I'm not going to go into, this guy studied it. Mostly all this fresh water is coming into this estuary, and it basically all ends up in the Bristol Bay, especially the place where Dillingham is. Lots of freshwater streams come in as well, and we went out and we started sampling this thing as I was using classes, but we were basically using fishing boats and very simple, this is basically a 3-meter outer trawl. And we just went in there and we collected things, we counted things, your classic stuff that you do. We looked at the things that lived there, basically dominated by invertebrates. A lot of people saw those shrimp and say, well, I didn't know there were that many shrimp there. Can we eat them? Well, I can't tell you we do that. And there's all kinds of other cool things like Sidoria, which is something that you Norwegians probably like, and especially in there's basically a Pan-Arctic isopod. And there's our species list, like you do if you're doing a study like that, and you look at species diversity and find out we ain't got much. We got really, really low species diversity. That was the first clue that something's going on here. And then we can do kind of zoning like we all do zoning, right? So here's my zoning based on some cluster analysis and stuff. And we have a river, upper estuary, and lower estuary. Mostly it's based on the species that live there. And then just to be fun, we did some bomb calorimetry, and we can do this. Now we know how we can know what you get when you eat something. All right, and so people Woods Hole is really excited about that, and we're working with them now. And then I put all this information on an online database. If you're interested, you can just go to this, talk to me about it later, and it's in really raw, terrible format, but it'll improve over time. But basically, what's happening is when you look at these species, they're Ice Age relics. Okay, they're mostly Pan-Arctic species, mostly. There's some exceptions, and they're hanging on by the fingernails. And as things warm, they're going. Good example is beluga whale. Beluga whales seem to be doing quite well there. They're not doing too well in Cook Inlet, but certainly we're at the edge in Bristol Bay. Another one is the rainbow smelt. That tends to be a more northern. You can find cold pockets further south, but as a species can be anywhere in the shallow water. That's an Ice Age relic. And of course, this beautiful isopod, my favorite organism. There's one with babies there. Basically, it's an Ice Age relic as well, Antarctic. I know you love it over there, and yeah, you know, well, it's a great species, isn't it? And one thing I did is I did some really, really evil experiments where I just put some, we did more than this, but this is just an example. We did some temperature tolerances to see, okay, if that's the case, are they going to survive if it warms up? And the answer is 15 degrees are fine. You just take them up to 20 degrees. They're dead within, you know, as you can see, just a few hours. You know, there's minutes there. Less than a few hours. So 15, they're struggling. They're not happy, but they'll survive. So therefore, we get to the primary and secondary production. So these are very turbid waters and strong currents. It's a tough place to live. Where's the productivity coming in? And we have a huge amount of fish in the summertime anyway, fish processing waste, which may hang around during winter. We don't know yet. So I think what we have is a detritus-based food web because we don't have the seagrass. We don't have the gigantic marsh grass. So where's all the food coming from? Salmon! And we've changed it a bit, probably as an argument, by putting in the processing plants. All that salmon waste would come down in some kind of dry, degraded form, but now we're intercepting most of it, grinding it up and throwing it back into the bay. So we probably have altered the system. It's a hypothesis at this particular juncture. We need to study more. So, ecosystem management. What do we find out? A few that's supposed to be sessile, which is missing S, benthic species. Most are mobile. In other words, you can't hang on to nothing there. None of those beautiful Paleozoic fauna that you see in the Barents Sea. I love those pictures. We don't have those. We have a bunch of mud. We have clumps of grass. I came in from somewhere else. Low primary productivity, low species diversity, and very low, mostly shrimp and chromatid amphipods. We went and talked about this at other places because that's a way that we, as in, hear it more instead of a scientific research paper. So we went to Alaska Forum of the Environment, we had a Alaska Estuary session, and we started discussing at that one. So we get beyond our region. We talked about our region already at the waste. So now we went to Alaska Forum of the Environment. We had a big estuary session there. And then we just had in 2015, we had a whole session, almost a whole conference dedicated to estuaries at the AAAS meeting. And we actually got into Science Magazine for it. A lot more to learn. Is that my out of time, or did we put it up? You haven't put it up yet?
I already did.
Thank you.